Hello and welcome. In this video, we are going to learn that how we can apply SRP while coding and while designing the software. So let's get started. Well, I've already shown you this slide and I told you that all these three statements over here means the same thing. They mean that a single class should contain a single logic or a single duty or a single algorithm as shown on the slide. At this point, I wanted to make it clear that these terms logic, duty, algorithm, responsibility, and reasons to change, these all terms are same thing and they mean the same thing. So if I pick one of them, then it means that I am actually implying all of them. For example, if I say that a single class contains a single logic, it implies that the same class contains single duty. It also implies that same class contains a single algorithm. It also implies that the same class contains single responsibility, and it also means that the same class contains a single reason to change. So in short, if I use any one of these terms or a combination of these terms, I'm actually implying all of these terms. So at this point, you might be getting this basic question that for a given problem, how shall we ensure to put a single logic inside a single class, right? So we can actually take a problem over here and demonstrate that how we can ensure to put a single logic in a single class and how we can follow SRP. So consider this simple problem, which says that given an array of integers and two integer I and j, we have to find the average of ith and jth smallest element in the array. You can stop the video if you want to and try to come up with a solution to this problem. Well, I'll just go ahead, and the solution to this problem is that we just sort the array and then calculate the average of a of I and a of j, because after sorting, a of I and a of j would contain the ith and the jth smallest element in the array. So, well, this is the solution to this problem. How do we code it? So let's start to code the solution to this problem. We can have a class whose name is average calculator, and on a high level it would take an array and it would take two integers I and j, and in the output it would give you the average of ith and the jth smallest elements. Well, now let's look at the logic which this class should contain. The logic which this class will contain is this. It would perform the sorting and then it would perform the average calculation as shown on the slide. Well, this architecture works fine and gives you the desired results, but we need to ask some basic questions to ourselves regarding this design and regarding this code. Does this follow SRP? Well, clearly no, because it does not carry a single logic or single algorithm or single duty. It contains multiple logics. As you can see over here, that it contains the sorting logic, that is, it contains the sorting logic embedded in itself. It performs the sorting itself of the array, and after that it performs the average calculation. The nature of these two logic is completely different and they do not deserve to be in the same class. Well, the question is then why they are in the same class. Well, the developer who came up with this solution and coded this solution can tell you that these two logics were dependent. The logic of average calculation was dependent on the logic of sorting. And this is important point to notice, because we know that you can do the average of ith and the j, the smallest element, only when the sorting is done, because after sorting, the a of I and a of j would contain the ith and the j, the smallest element. Well, even though the logic might be dependent, the logic of calculation, average calculation, might be dependent on the logic of sorting, but then also they do not deserve to be in the same class. So to address this problem, there are two approaches. One approach could be that in the average calculator, it does not contain the logic, the whole logic of sorting itself. It can actually delegate the call to out-of-the-box APIs which are provided by Java, which could be used to perform the sorting, and then it can perform the average calculation. And in that way, this class, whose name is average calculator, would contain the core logic of average calculation only, and for sorting, which is not its core logic or core responsibility, it will be delegating the call to the out of the box APIs provided by Java, and that's fine. And in that architecture also, we can say that SRP is being followed. Another approach to solve this problem is that average calculator does not contain the whole sorting logic itself, but there is a different class whose name is sorter, and it contains the sorting logic in itself. And we can choose to have bubble sort or insertion sort or any kind of sorting inside the sorter logic. And we can say that average calculator does not contain the sorting logic itself, but makes a call to the sorter class and passes this array in order to do the sorting, and after which average calculation is performed. In this way, we have a sorter class which contains the sorting logic, and average calculator just uses it. In this architecture, we can say that sorting is being controlled from a single place, which is sorter class, and we can control the logic of the sorting from this class as well. And another part of the application can also make use of the sorter class. In this way, all the sorting that is happening in your application could be controlled from a single class itself. So now in this overall architecture, you will get the desired results. And if you ask yourself, or if you observe this architecture, this follows SRP. So now each one of the classes that are shown on the slide contains single logic or single algorithm or single duty or single responsibility. So what we have learned in this video is that if you are given a problem, then first of all, you have to come up with a solution, and the solution has to be further broken down into pieces and logics, and you have to identify the particular pieces of logics which are totally different from one another, and then you can design the classes such that each class contains a single logic. And then if there is a dependency between those logics, let's say logic A is dependent on logic B, then it can make a call to logic B. And if logic B is dependent on logic C, then again it can make a call to logic C, and so on and so forth. Thank you very much.